Morning. You guys up for tea, coffee, tea, beer, wine? Yeah, okay, so we're going to, I think the plan is to go through some computer vision. And I think instead of giving a lecture, I thought I would just give a tutorial on just some idea about an end-to-end sort of thing. Can you take images and sort of the thing we are doing with the low range, so this afternoon we're going to collect camera trap data. And so the idea is that if you collect data from there, say an image, can you process it and send some sort of result back up to a server or to wherever you want the data sent? So some sort of end-to-end thing, image or video or whatever it is, do some processing on it and then send it all the way up. So I don't know if how many of you downloaded or sort of installed the things we had on what was that thing? Pre-workshop, the pre-workshop tab. Okay, just a few. All right, but you all have Anaconda, right? Okay, so we're going to switch it up. I thought I would use OpenCV, but then I figured most of you would not have it installed. So we're going to use SK image. Who has used SK image? SK scikit image or SK image? No? Sort of like OpenCV, but it's like sklearn. Who has used sklearn? Okay, most of us. Great. So like sklearn for doing image processing. It's called scikit image. Normally comes installed with Anaconda, so you should have it. We should try it and see if you have it. Okay, let me try and get my notebooks set up. Yeah, so Mike is putting it up.
But you need to go to the IP address again. It's kind of annoying. So it's not just if I was to share the IP address? Yeah, 172.16.34.214. Maybe someone could invent some sort of naming system for domains. It's the same.
So the IP is what?
Yeah, 172. 16, 34, 240, 214. Mine is made up of
All right, so if you go to this IP with the hyphen, with the apostrophe there.
I don't know why there's an apostrophe.
All right, if you go to that IP, you can download the notebook. Should be called something like, it should be a whole folder called computer vision.
And you need to connect to the Data Science Africa Wi-Fi network.
Or we could just pass it around on flash disks.
That's the actual, the Wi-Fi is the box.
Is it your local? But so a good example would be just to open up a notebook, since you're ready now to do it, and try and run these imports and see if it actually works on your system. That would be a good.
I've only got 5. There's 5 that disappear, yes. Well, actually they've got they're making Mwebaze and I guess they're on the white, like oh, is that what this is? Okay, right, fair enough. I'm surprised that even without that would be. Maybe that's worth future investment. The South Africa massive commercial Wi-Fi hotspot.
So if you run these, if you just put in import SK image, skimage, I don't know how they pronounce it, sky image, skew image, whichever works, then you should, there shouldn't be any error. Yeah. Normally when you install Anaconda, it comes bundled in, so it should be there. But you should try it, that's the whole point. Try it and see. Anyone needs a... No? You have a widen? I widen a bit. Oh, they okay. I thought you meant me. All right. So does it run? Do you have the files? How many have the files? No, how many don't have the files? Ah. With needs the files? All right, so you have SK image working. So I won't use. All right, so we'll just continue. So this won't be long. So I just want to show you some, maybe an exposure to SK image if some of you haven't used it. So it's quite good. So you don't need to install many libraries like OpenCV. It sort of comes within Anaconda. Everything works well with matplotlib and everything. So basically once you've imported everything, then the idea, so the basic structure of the talk is I'll talk through images, a bit of what processing images looks like, and hopefully get through to some videos, and hopefully you can process some videos of what you are doing yesterday. That would be cool. That is the golden standard. And also, hopefully at the end, so yesterday Billy told me about YOLO version 3. So I managed to download it, very easy to download. So it's already a pre-trained sort of network that can run on the fly, and you can actually use it to sort of classify like 1 million images. Can actually be used quickly with the camera trap data without OpenCV. So. Yeah, well, this one doesn't need OpenCV, so it just runs off the. Yeah, so that's the man. Bill is the man there. Okay, so all right. So what are images? So yeah, so you can read in an image. So if you have the things, you can read in this image where we're looking at this thing, which people called so some people call this animal here a giraffe. I think the group I was with. There's a dodgy group, but anyway. So it's a llama, I think eventually we go to understand. So if you can read in an image, if you don't have the files already, you can get an image you have on your machine. and try and read it in. So that would be the command, and then you can sort of show it you can sort of show it with matplotlib. Okay, so this is going to be important. Does everyone have some sort of image there? So an image basically is a bunch of pixels, it's a bunch of numbers that have been quantized. So the good thing with the plotlib here, matplotlib, you can actually see the range of the image, and so these actually relate to different pixel values, right? So an image is sort of a combination of three. When you have a colored image, then those are sort of three images combined together. So you have a red image and a green image, red, blue, green image combined together. So if you look at the size of this thing, if you get its shape, I don't know, you sort of see it's, well, it's a bit further ahead. But if you get that image, you can actually crop it because the image is represented as a NumPy array, right? So it's just an array of numbers. So you can actually crop things out of an image very easily. So if you wanted to do some manual sort of processing, so for example, here I'm just cropping out the sky. You know, it sort of moves from, so I'm just cropping out this region of the sky from 0 to 200 and from 400 to 800. So this portion of the sky, I can just cut it out. And show it, right? Okay, so the images, as I said, the pixel values can range from 0 to 255. If these are bytes, they're represented as bytes, unsigned bytes. Bytes are 8 bits, so 2 to the power 8, 256. So you have a range of 0 to 255. So 255 being white and black being 0. Alternatively, you can also have them range from, actually they can range from anything. So long as you have white on one end and black on the other end, then all the colors can actually be derived from that range. So you have 0 to 1 as well, which you can use to represent images if the pixel values are represented as floating points. But to get you guys on board, have you loaded the image, any image? Does it work? Okay, so the idea is, can you do some small cropping? So the first exercise, well, okay, here is so if you crop out, if you really go down to just the lowest parts of the image and you plot them, it actually gives you these things. So this is actually what the pixels look like. So the pixels, once you really go down, once you really zoom into the image, these sort of look like, these are what the pixels look like, right? So this is just a zoom in on the sky. And I think it's, I'm zooming in on some corner here, right? So from 198 to 200 and from 396 to 400. So very few, just these pixels. And once you zoom into the image, you actually see that the pixels look different. So the whole point of image processing and computer vision is really to process these pixels, which are just a bunch of numbers. So you can think of any function that deals with numbers can actually do very well with image processing. It's just a bunch of numbers that you keep processing. Of course, the idea with images is that they're related, right? That pixels that are next to each other tend to be related. So deriving that information from pixels is generally what we are trying to do most of the time, right? Which pixels sort of give you some information about something. But really, they're just a bunch of numbers. Okay. Okay, if you have these files, do you have these files? If you have these files, one small exercise would be, can you actually crop out the llama? Can you cut out that llama from that image? You know what the llama, the giraffe, for those who saw it as a giraffe. So just crop out using, just cut it out manually using, just slicing. I think yesterday Ben talked about slicing. Yeah. So you can load the image as when you load it as a color image, it's a three-dimensional image. So you have, each color is formed by RGB, RGB. So it's, so for example, this sky image, you have sort of a 200 by 400, and this is layered thrice. Right? This is the three, so it's a three-dimensional RGB, yeah, RGB. So you can actually just crop out the R or G or whatever. Or you can also load the image as a grayscale image, right? Where you just have, it will be a 200 by 400, and all the pixels will range from 0 to 55, and they're just representing a scale from black to white, which is gray. All right. Have we managed to crop out the llama? It's called lammarization. It's a term in computer vision called lammarization. Very important. New term. Okay. Who has managed to crop out the antelope or the llama? No, who has not managed? I think that's a better way to do it. All right, no hands. We'll move on. So generally you have this computer vision and image processing, and there's a slight difference between them, but generally they tend to be quite related. Overall, image processing is some sort of step towards computer vision. And image processing, you put in an image, and normally the output is some sort of image which has been sort of processed. With computer vision, you're interested in, yeah. Mm-hmm. This? Yeah, 8? Oh. Where I put this? This I guess I just wanted to show that you can also just get only a bunch of the. You can also just slice out a bunch, just. Oh. All right. So I guess computer vision sort of has some idea of taking in an image and returning some sort of information. And normally the information may not be an image, but may be a number. So for example, the camera trap data want to collect in the field. Maybe you want to come up with a number, a binary number that relates to whether that a llama has passed by the camera trap or not. So this would be sort of an idea. Get an image, figure out whether there is a llama, and return a binary yes, true or false, if there is a llama or not. All right. So sklearn has several other tools. I won't really go much into them, but this is some idea of processing. So I think we've been talking about Gaussian filters and Gaussian kernels. And so one way to filter images, you can... So normally processing has some sort of filtering where you're either denoising the image or you want to, as I said, so related pixels which are near each other sort of have some relation. So if you apply some sort of Gaussian filter, then you can sort of average pixels out which are near each other if you want to denoise, for example, an image. And this is sort of one example of doing that with SK image. So you have the image, okay, maybe this thing here. So this is just reading in the image as a grayscale image, as a gray image. So you have an image where the pixel values represent the levels of gray from 0 to white. This tends to be easier to process. And you apply some sort of filter, and this is sort of the, you can call it, the sort of the width of your Gaussian, right, sigma. And you can change this. By changing this, you sort of see the image changing. You can, and maybe you can try this out. My images are not too clear here. But so here what we're trying to do is, given an image, you want to separate the background from the foreground, right? So given this image, for example, maybe you want to see if we can identify, I don't know, maybe the llama, right? Maybe you want to pick out the llama or identify people from this image, right? So you want to be able to sort of say, okay, this is the background that I don't need, and this is sort of the foreground, and then maybe from the foreground I can extract something. Just an idea. And one way to do that would be to sort of so you can take a mask. So here what we're doing, we are loading the image as a grayscale image. We're converting it to float. So we are making sure that all the pixels range from 0 to 1. We apply some sort of Gaussian filter, sort of denoise, smooth the image. And then we do a copy of the image, and then we find the minimum value of the image, right? So we find what we think is the minimum value of the image. So these are all pixels here. And so you want to find the minimum value of the image so that you can subtract out the background. So you can imagine that that maybe the foreground is brighter than the background. Maybe the background is black. For example, to identify the llama. It has brighter pixels than the background. So you can identify some sort of pixel which is the foreground, less than the white, and just by subtracting the image from this sort of mask, you can get another image, right? So this is what we're doing here. So again, the major point here is that images are just numbers, right? So you can actually subtract them like this, right? Oh, this is just plotting. And you have some sort of reconstruction, some sort of morphological processing step here that sort of takes the image and does a dilation, right? Expands the parts that are bright in this case. And then you can have your output image, which is just the image minus the dilated image. And you can sort of plot these things and see what they look like. So by changing these parameters, for example, by changing this sigma here, you can actually get a different sort of image here and a different output. So this would be our sort of output. This is our image. We've sort of processed it to some sort of image like this. So we've blacked out the sky. It's not too clear here, but I think you can see sort of the llama there and this guy here wearing the white shirt. I don't know who's wearing the white shirt at Data Science Africa, but okay, won't go into that. But you know, you can sort of cut out all the other stuff and focus on the llama, for example. Try and get the brightest part of the image. Okay, this is sort of an expanded part of the thing. You can try some of this stuff. Okay, so once we have this image processed, what can we do with it? So we can do things like get contours. You can do many things with this, with sort of computer vision. And there's, if you go to the gallery of SK image, you can sort of see many sort of examples of how to do this. But this is just one. You can sort of find contours. So contours are areas where the gradient tends to be sort of uniform, right? So for example, where, you know, for this white guy, the shirt here that's white, you sort of get a contour around that. For our llama, and so you can do different things. So for example, if your image sort of is taken in such a way, imagine our camera trap is so near the path that if it took an image of a llama, the llama would be the biggest part of the image. Then a very simple thing could be to do this, get a contour and sort of look at all the contours and rank them based on area. So maybe if you get a really big contour sort of representing a white thing, maybe that could be a llama, right? And then you could sort of send how many, you know, you could do a very simple thing. Say, I find the number of contours in the image. I get the ones which are of a certain size X and say, okay, if my contour, if I get a really big contour that's significant, that is white, that has a size relative to, for example, the size of my image, that is X, then maybe that's an animal, right? Ordinarily, if you think of the camera, maybe it's just without anything passing, it's just taking many leaves, and maybe none of those can have a big contour. So you could just send this. So this could be something small to send on from the camera trap sort of thing that takes only 20 bytes per minute. Okay, so you can sort of try this as an exercise. You can sort of try it with different images. Also, you can load different images. So you can try different images and see how this works out. Yeah.
Well, I'm watching the agenda. All the spatial data analysis, will we be talking about satellite image analysis or?
Sorry?
Will we be talking about satellite image analysis, satellite images, or will we be talking about that?
Satellite. I don't know if someone will talk about satellite images. Maybe Max. Oh, spatial data analysis, John. Yeah, probably. Probably. If it's nice linear. Yeah, I mean, images are probably images. I mean, if you have satellite images, you can probably identify different things from there. So same techniques can actually work. And there's different papers of guys using SK image to do satellite imagery. So you can actually look that up. But I think John will do that as well. Probably use OpenCV. Okay, so yeah, so you can do different things. So this is not clear here, but I'm sure on your machines is clear. So yeah, so there are several things. well, there are not too many, but one of the key things that people try to do with image processing and computer vision, one is to sort of discover image identification. Can you identify an image? Can you identify certain edges? You could identify different features in an image. So you could use things like canny edge detection. Here you can't see it properly, but you can use this with sort of other algorithms to discover things, like if you wanted to discover round things in your image. For example, you want to, given one good assignment would be just to identify faces of people, round blobs in, for example, an image. That may be an easy thing to do. And so you can do these processing steps and sort of get to that level. Yeah, canny edge detection is really a cheap thing for getting edges. If you want to get edges, it's not clear here, but you can sort of, by changing this parameter here, you sort of restrict it to get different edges. So if you have a very clearly outlined thing, if you want to, I don't know, track a road, get a road, or whatever it is that has clearly defined edges, this could be a good technique. Right? You can also use something called half transforms to get objects. So there are many things you can do with this. But the whole point here, what I wanted to show is that you can do several things with an image. Right? So what we have now is we've taken some sort of image, done some bit of processing, done some bit of identification of the llama, and there's several things we can do, and you can sort of try them. One interesting thing is template matching. Yeah, so if you have very few images that you can't sort of train a very good sort of recognition system, right? So for most of the neural networks, you need vast amount of images. But if you have a very unique thing, few images, template matching was something that used to work, or that could work for a very simple system. Right now, it's sort of old school, but you could still use it. And it has very simple commands. So this is all plotting. So this is all you need to write for template matching. Get some sort of template. And for this, we got some sort of, I got some llama image from the net. And then, yeah, just run match template, give it, your template and whichever image you're sort of processing. And then, it should sort of look for the image in. And for this one, it sort of works quite well. So those two commands, this is the thing I got from the net. This is our image with the llama. And this is sort of how it identifies the thing. And this is sort of a mask of this image and points where it sort of thinks there's a llama. Right? So all the points which are bright green, it sort of has some prediction of whether there is a llama there or not. And the highest is this area here, which is this. So, relatively, okay, so this and you can sort of figure out how to draw things on the thing, but this is all preprocessing. So yesterday Mike sort of talked about how do you actually make this reproducible. Right, so one idea is to sort of write a function that does everything. So ideally what you'd want to have is to write some sort of function, process image that takes the image, calls or whatever functions you want it to call, and return maybe an image or return some sort of result. This would ideally be the way you would want to do this. Yeah, so your assignment will be to sort of take whatever stuff is here. There'll be a link to, you can go to sklearn and look at the gallery. You can do whatever you want to do with these images. But the idea is sort of get something from this stuff and put it in this function here. Process image. Okay, and once you have that function, now you can sort of work with videos. So videos, Videos are really just a series of frames, right, of images. So images that are sort of put together, that forms a video. So exactly the things you do with images, you can do them with videos. You just have to get the video and cut it, slice it by frame. And there's several ways you can do this, again, with Python, without doing a lot of stuff. So you have this Mwebaze editor. Mwebaze is a library that does a lot of, if you want to process movies, like reading videos, process them image by image, or write out videos. Say you're processing many images and you want to write out these images as a video, you can sort of do this, right? And so what would and so you, very simple, again, sort of one-line thing. So this is all you call. So you have our function here, sort of process image, which takes an image and returns something, and you call it on some video clip, and then what it will do, it will take all the different frames and process them sequentially, and then create another video. In this case, we are outputting another video, right? And you can sort of put the video here. So if we had some processing, so ideally, so what is happening here is really nothing. So this one just takes an image and returns the image. So the video which you put in will be exactly the video that you get out. So once you've put some code here, so you can think of anything. It can even take the image and just return a different color of the image, right? And once you have that, then you can sort of create a video that shows you output, right? So this could be a good sort of thing. And you can also do a webcam. If you had a webcam sort of looking at images, you can do the same processing easily. Sorry, new application? I mean, the new developments are with neural networks. I mean, you know, CNNs, this sort of thing. I think the idea is really finding new ways of using it. I mean, it's not really that old, actually. So once computers got faster, then, you know, it became, and, you know, once OpenCV came out as a library that people could use, then it became possible to actually process images, you know, very well, quickly. I think the idea was really speed. Can you do it really? Because, you know, most of these operations are operating on these little pixels. So these are very many numbers. So the calculations are quite many. But once we got processing and GPUs and all these things, now you can do this much quicker. I think the thing here with Data Science Africa would be to find sort of innovative ways of using these images, right? So for example, in Uganda, we use them for doing things like detecting crops. So given an image of a crop, yeah, but this we'll discuss. It's not completely different. I mean, it's exactly the same thing. We do. You want? Yeah, so I think basically the idea was to really show what a pipeline would look like all the way. So one quick thing which is in your folders is the YOLO. So this already built network that you can easily run on your system very quickly. And let me see if so if you install it, let me see. Okay, so I want to show you this yellow thing. I think it's pretty cool. So if you install this yellow thing, so I've the files I gave you have maybe let me. Okay, I already have mine installed, and what happens is once you run it on any image, you can run it from the shell. You can get some sort of, for example, you get quick results. For example, this I just got this network. I got the tiny version of the network. Run it in, I don't know, 2 seconds, no, 6 seconds. And you sort of get, it can give you some sort of classification of whatever stuff is in your image. So let's run it on our llama image and we'll see what happens. If it says antelope or giraffe, oh, giraffe, jeez. Oh man, okay, so guys were right. The guys who said giraffe, you know, we can, you're good to go, right? So, yeah, so this runs very quickly. And so the code I gave you, I think that folder, I sort of created a notebook where you can write some Python code to actually do this stuff in the background and run this thing, and you get some sort of,
What is it called?
I think it's called YOLO 3.
Yeah, there's problems. Hard-coded URL in it.
Is hard-coded URL? Oh, wait, let me see. Okay, so where is hard-coded URL? Oh. Yeah, so it needs a bit, some bit of tricking. But anyway, so you can load it once you sort of just install this thing, which takes like, 3 minutes to install this darknet. I don't know why they call it darknet. No. Anyway, so you can run the code in Python, and it gives you detections like this, right? So it gives you, for example, for example, in this image, it will give you this image, the class car had some sort of probability, and then the location of where that car is, right? So you can actually draw a bounding box over your image, right? So you can actually have, and what I was hoping you guys would do was to take the YOLO code and put it in some sort of pipeline like the one we just built, where, the images come from a video, they are scored, and then it can even send back things like this. So this is sort of the data you can have coming on our from the camera trap data over this low range sort of transmitter, right? Because you just have sort of the class and some sort of probability and some location, right? So if you had the original image saved somewhere, you can actually draw the bounding box, or you can sort of say, okay, seems a giraffe passed in the conservancy, and then we'll know it's a llama. Yeah. Okay, so yeah, so it's a bit here and there, but that's the idea. So the goal, your goal would be to take, if you can take some of this stuff, particularly take maybe this YOLO stuff, it's a pre-trained network, little installation, put it through some notebook or whatever, and then you can sort of run something like a video. Right? So imagine you have some sort of camera recording a video, and you can sort of process your images through this and get an immediate classification. I think that would be cool. Okay. Yeah, so I think basically that's it. So this was just really some sort of introduction to computer vision, but I think all the other lectures that will come from here will sort of build up on these aspects. But it will be exactly the same thing. You sort of have some function called process image. It doesn't matter what function, whether it's some CNN or whatever it is. And then you sort of have this pipeline. Just output some output, and then you want this sort of pipeline coming, giving you some output at the end of the process. Okay. Any questions at this point? Yes, sir.
I was thinking about avocados, yeah? So when we talk about maturity, they usually mature when they are from light green to dark green, okay, depending on the species. So taking a particular species. So if we take the image, just from light green to dark green, and maybe we have to label one as mature, others are moderate and immature. Can you use this one, and if you have a production line where you have to take the image of this avocado and determine in a second that it is mature, or remove it from the production line or the packing conveyor belt, is it possible using this computer vision?
Yeah, so the biggest problem with computer vision, I guess, is really the images, the quality of the images, right? So it's very hard to control occlusion, light, and all these things. So the algorithms try to do that automatically, but it's in many ways, for a practical system, you want to try and make sure that you're controlling the context in which you're taking the image. So if you have a very good context, say, for example, you have a system which is lit with some sort of device like a camera taking a photograph of the avocados as they pass, and maybe they have some sort of uniform background, you can get a lot of mileage with that. So it can work, definitely. So given an image to detect whether it's light green or dark green or medium green, that is possible. But then you'd need sort of this whole system to make sure that what you're getting is actually accurate. Otherwise, small things like even a shadow have some effect. And especially on determining things which are that close, whether it's light green or dark green, you need to make sure that you're controlling the environment. But it's possible. It would be a simple, you can write it now as well. Be a good exercise if you have avocados. Okay. If there are no more questions, then yeah, so I don't know, tea time?
According to the state of art now what is the best tool for computer vision? If you want to choose between SK Image, OpenCV.
Well, the state of the art, most of the things are now sort of, you can sort of use neural networks to do a lot of the computer vision stuff. But some stuff, you may need some preprocessing And it really depends, these things are more or less the same. It depends on how you're implementing it, what your system setup is, what your deployment setup is. I mean, some things like maybe Damon will tell you has been trying to put OpenCV on there. That's taken forever. Maybe a simple thing that's really based on Miniconda or something can work. So that tends to be the thing. Or do you want to put it on a phone? And then there you go. Yeah. Yeah? No, I didn't use it here. No, this is plain SK image. Yeah. But maybe that's used under the hood, but I didn't use it here. So that's the beauty with this. It sort of has a few packages. They're all integrated in there. You can just call it, especially for prototyping. Very good. Okay. So, yeah. So I encourage you to sort of go through the practicals, and then if you have any queries, you can sort of look us up.
Thanks, Ernest. I think it's time for break for half an hour and then come back for the data visualization session. Yeah, we have some few flash disks going around for the, and it's also available online. The local on the data
It's actually called local DSA now.
yeah.